Good morning, Hoptown Middle students. This is Mr. Martin. I want to talk to you about negative exponents today because we've already discovered what it means for a base to be raised to zero power. We did that on our previous slides, and we know that anything to the zero power, no matter what, is going to be a 1. We also already know by review what happens when you have a positive exponent. You're just multiplying that base by to itself the number of times the exponent tells you to. For example, this 10 to the third power is really 10 times 10 times 10, which is 1,000. 10 to the second power is really 10 times 10, which is 100. And 10 to the first power is just a 10. Well, the question we have for ourselves is, well, we know what to do with a positive exponent. We know what to do with a zero exponent. Well, what do we do with these negative exponents? Well, to understand this fully, you're going to have to continue your patterns that you had when you were looking at the zero exponent. Meaning that when we go down an exponent, what is happening? Well, in the case of base 2, every exponent you go down from 2 to the third, to the second, to the first, and to the 0, you're dividing by 2. Well, the pattern doesn't change when you get into the negatives. So what you're going to do, for example, to find out what 2 to the negative 1 is you're going to take your 1 and divide it by 2. Now, what you want to do is essentially say, well, it's 0.5 or 5/10 because you tend to prefer to have decimals. Well, if you try to turn all these things down here into decimals, you'll not see the pattern that comes around. The shortcut you can do to keep yourself from having to divide over and over and over again. Well, another way to express 1 divided by 2 is by showing it as a fraction. That is right there, 1 divided by 2. So if that's 1 divided by 2 and it's a number, a partial number, you can still represent it as 1 over 2, which is 1/2. Well, if that's what happens here, what happens with 2 to the negative 2 power? Well, you're going to take that 1/2 and divide it by 2. Well, if you take a half, and I'm going to make a quick little circle here. You take that one of those halves and you divide them by 2. Well, what's 1 part worth now? Well, it's worth 1/4. And you take that 1/4 and you divide it by 2. Let's say we take this 1/4 and divide it by 2. We'll go ahead and do both sides. What's each part now worth here? Well, there's 8 parts in all, and 1 part's worth 1/8. Well, you're probably sitting there saying, hey, wait a minute, hold on. We have a 2 for 2 to the first power. Down here we have a 2 negative 1 power. It's a half. Up here to the second power we have a 4. Down here we have a 1/4 for our negative 2. Up here we have an 8 for 2 to the third power. 2 to the negative 3 power is 1 over 8. So can I just take my numbers up here and essentially flip them? Take its reciprocal. And you can, as long as you're evaluating them. But if you're just simplifying them, that means they want you to leave it in exponential notation. They will still want to see the exponent there. What would you do then? Well, a half, you really don't have to do much to it. I mean, you can sit there and say, well, it's 1 over 2 to the first power because it's a 2 by itself. What is 4 really, though? It's 2 to the second power. And what's 2 to the negative 3 power? Well, what's 1 over 8 really? It's 1 over 2 to the third power. Now you can really see a relationship between positive exponents and negative exponents. Well, let's go over here and think about what happens here. If we simplify this at first and just simplify before we actually give an answer, to write 10 to the negative 1 power, we would put 1 over 10 to the first power because we just want to flip it. We're taking our 10 negative 1 and we're flipping it. And when we flip it, our exponent turns positive. And that's really just 1/10. And as we know, if we divide 1 by 10, we get 1/10. Well, what is 10 to the negative 2 power? Well, if we take our negative 2 and flip it, we would end up with 1 over 10 to the second power, because if we divide 1/10 by 10, we would get a 100th. And 100 is really just 10 squared. Well, if we did the same thing to 10 to the negative 3 power, if we simplify it, we would really have 1 over 10 to the third power. Well, if we evaluated it, we would have 1 over 1,000, which is 100th divided by 10. So this is what's going on with negative exponents. We don't really have negative numbers as our answers. What we have is smaller numbers. Our numbers keep getting smaller and smaller as we take away an exponent. They actually become fractions or decimals. You can convert these to decimals. It's just decimals won't help you understand the pattern because there is a relationship between a positive exponent and its corresponding negative exponent, whether it's base 2s, base 10s, base 3s. It doesn't matter what the base is. There is a relationship. We're going to explore more of this relationship tomorrow. But for right now, what we're going to do is write a little, just a little. What we're going to do right now is write a little rule for this. And that little rule is essentially just something that we can do, a shortcut to keep us from having to evaluate, keep us from doing these tables all the time. We can keep doing tables all we want to find the patterns here just so we can understand it better. But really the rule for a negative exponent, and I'm going to write negative exponent, and I'm going to put it on the next slide too, typed up for you. But a negative exponent, the rule for it is, I'm going to use it, just go ahead and use what I'm going to do first is just go ahead and use our variables. So I got b for base, and I'm going to put a negative e for the negative exponent. What you're going to do to simplify it, and when they want you to simplify it, they want a positive exponent. But what you're going to do is essentially put a 1 over it, and then move b to the e power into the denominator, and that will turn it positive. So basically what you're going to do is you're going to turn the expression to its reciprocal, and make the exponent positive. And I'll put this on the next slide. I just want to talk about it here first, and then I'll put it on the next slide typed for you, and that way you don't have to worry about my kind of poor handwriting here. But that's really what you're doing. Now this right here, I would go ahead and write down. Okay? Because this is really what you're going to probably want to remember, because this is really your algebraic rule right here. Okay? So this has been Mr. Martin's tutorial or how to deal with a negative exponent. I hope you guys come to class ready tomorrow, because we're going to do a little bit more work with this, because it's going to take a little while to get used to. I hope you guys have a wonderful night. See you tomorrow.